In investigating electrostatics, there are a few things that we've noticed. First, if we take some charge Q and we take a second charge Q, where these two charges are identical, so they'll both either be positive or negative, they'll repel each other. And the repulsion is going to be equal and opposite. If we take the same two charges and we bring them closer together, the amount of force that's experienced by each particle is going to increase. This is described by the inverse square law. And if we look at what happens, we're going to plot force on the y-axis, and we're going to plot that against the separation of the charges r. It follows this type of shape. And so what we're going to have is that the electrostatic force is going to be proportional to 1 over r squared. This is one of the things that we see when we investigate electrostatics. But there are other things. One of the other things that we notice is that if you take the same charge, so we're going to have Q, and what we're going to do is we're going to have the charge on one of them. So we have Q and Q over 2. And what's going to happen is the amount of force that each experiences is going to be decreased. Again, it's going to be equal and opposite on both charges. If I take the same charges, but now instead of having one, I double one, what we're going to find is that at the same distance, what's going to happen is that the force is going to be increased on each of them. This tells us that what we have is that as you increase the charge, you're going to increase the amount of force. If you decrease the charge, you decrease the force. We end up with something that we call Coulomb's law. And Coulomb's law simply says that the electrostatic force is equal to Coulomb's constant multiplied by the magnitude of charge 1 multiplied by the magnitude of charge 2 all over their separation squared.